Hi everyone. So this is Suresh. See, so today we are going to see one important concept called collection frameworks. So like how the collection frameworks are introduced in Java. So before going to discuss in collection frameworks, so we want to know what is the like purpose of the collection frameworks and what is the use of the collection frameworks. So first we need to see. So and once we identify the purpose of the collection frameworks, so we can move to the and what are the classes and what are the interfaces are available in our collection frameworks. So for example, have a class. So the class name called student. See, so the student class having student ID and student name, student address, email, and contact number. So these are the properties of our particular student class. So let me expand. See, the student class. So I define in which package it is in com.java-technology.model. So what I am doing here, I'm creating multiple objects. So I'm creating, see, I created one object here. This is the way to create an object for the particular student, and I'm added some values to the particular student object. Like ID is 123, and name is Java Technology, and address is Hyderabad, and email is some javatest.gmail.com, and you set contact number. So I'm printing only the student ID, right? So I if we observe, the output is showing 123. So what we given as a student ID 123. So this is then a simple application like the single object we are trying to create in our. So this is in our program. So now what I'm doing here. So I want to create multiple objects and I want to store multiple objects. So if we want to create multiple objects, so what is going to happen here? So we need to copy, we are going to create multiple times. So this is the way we are going to create multiple objects. So like 1, 2, and 3. So this is the way we can create a multiple object of student. So now what I'm doing, so if we want to access all the objects at a time, or if you want to store all the student object in our collection or in our any, so like what we can call it as any memory locations, and we want to access all the objects one by one or at a time, so we cannot do without collection frameworks. So this is the purpose of the collection frameworks are introduced to store multiple object, and if you want to get multiple object one by one, or if you want to get object at all, so we can use the collection frameworks to to get these kind of features. So because of these, so the collection frameworks are introduced. So here what I'm doing, so in our collection frameworks, so we have one important interface call is a collection. And so before going to write our flowchart of the collection frameworks, so I want to go like I will provide some information. So the collection framework has so divided into the two parts. So like so one is collection and one more is map. So first we'll see the collection, so how the collections are is going to work, and once we like we are very much like we are ready to develop any applications using the collections, so then we can move to the map side. So how the maps are going to work we will see. So first I am going to write the collection, the flowchart, how the collections are going to implement it, and what are the methods are available, and what is the purpose of each method we will see. So this is an sorry. So this is an interface, and this is the top most like is the top interface we can call it as, or we can call it as this is the main interface also we can call it as. And we have sub interfaces called, so list, and so we have one more interface called set, and we have queue. So these are the three interfaces are these are the three interfaces, sub interfaces of our main interface call is then a collection. So how these are is going to work. So let me here, let me take our draw. So this is our main interface called collection, and so these are the sub interfaces. These are not classes. And before going to provide some information on the interfaces, so we want to we need some basic understanding of how the interfaces and the classes are is going to work in Java. So if we doesn't know anything about interfaces and classes, so this class, so we cannot get the we cannot understanding how the flow of execution, so how the implementations classes are is going to work, so we cannot get it. So we need some basic clarification on how the interfaces and classes are going to work in our Java. So if you know, so I can move forward. Otherwise, I can go to the previous section. Like I will discuss interfaces and the classes. After that, we will move to the collections. So if we have any queries, we have the one chat box is available in meeting. So you can comment. So I will see so what type of issues we are facing, so that I will try to clarify your doubts. So if you don't have any doubts, so I can move forward. Okay, see, I think no one having any doubts. So I'm moving into the same collection. So here, using the collection, so we can store multiple objects. So how we can store? I'm going to provide some basic example how the collections are going to work. So here we can see. So this is our student class. So these are the student object. So these are the okay. See what I'm doing here. So just I'm going to create one collection class, how the collections are is going to work. So this is a basic example I'm going to use. So as I said, so this is a list. So it's going to take some students, and we need to implement this student using java.util. So I will explain what is java.util. New array list. So simply I'm storing array list. So these also we need to import from java.util package, and we need to use list.add. So the list.add is going to take the student object, and I'm going to pass as a student one object. So here the second time I'm going to store student two, and I'm going to add. So like this is the way, so we can add multiple object into our collection object. So this is the one of the collection object. So don't worry as of now. So how the array list is going to work, I will explain. So just what I'm doing here is, if we want to store multiple objects, so this is then a user defined class, we can call it as. Student is an a user defined class. User defined class in the sense, so we are only creating an object for the particular class. So because, so this is the student as an like model class. So it's having some properties. These are the properties. So in our, so just imagine, so we are going to develop one, like what we can call it as college related application, so that we need to provide the student related information, so that we are going to create an object of the student, and we are passing into the collection object. So these collection, using this collection object, so we can like update the particular student object, or we can delete an object, so we can like save an object, or if you want to, so like save multiple object at a time using this array list any collection object. So we can easy to save, or easy to delete, easy to update. So this is the operations is going to perform using our collection frameworks. So this is all about the basic understanding of collection framework. So now, so we will move to the collection, how the collection interface is going to work. And so as I said, so this is our main interface of the collection frameworks. This is known as a collection. And the collection having some methods. So because it is an interface can have only the method definitions. So the method implementation is provided by some implementation classes. So I will provide, so who is the implementation classes and how the method, each method is implemented. So we will see. And I'm going to provide information for the collection interface methods. So now we want to see the collection method interface is called. So like what are the methods are available? So here, so this is the boolean add method is going to take what is is a some generic type. As of now, don't worry how the e is going to work and do. So it's going to take one parameter called object. So using the add method, so what we can do, so we can add a particular object into the our collection object, right? So if we want to add all object at a time, so what we can do, we can use add all method, and is going to take collection as an a parameter, collection as an a parameter, right? So this is the way, so this is the way these methods are going to work. So just our previous example, we used the same thing. So same, the previous example we used only add method to add on our particular object into the collection framework. Same thing, we want to remove an object. So what is going to take, we have clear, so void, so this is the clear, right? So now how the clear is going to do, so like, so I will give an example. So using this all the methods, so how these methods are is going to work, so we will see. But first I'm going to write the methods, how many methods are available in our collection interface. So now, and this is the clear method. And if you want to know the particular object is available in our collection, so what we can do, boolean contains, we can pass object as a parameter. And so we have another method called equals. If you want to compare the two objects, so we can use So equals method. So equals is going to take one more object. So now, and what are the methods? And the collection is an empty or not, using, we have the method called is empty. We have the is empty method. So, and one more thing. So if we want to remove one object from the collection, so we have remove method is available. And if you want to remove all the collection objects, so at a time, so we can use remove all. So this is the method is available in our collection interface. Just see, don't confuse whatever the methods I'm writing. So those methods are related to the our collection interface. చేస్తా ఉండు. So now we want to know about the size of the particular collection. So we can use we have the method called size. We have the method called size. Using the size method, so we can easily identify how many objects are stored in our collection. So same like so yes. So these are the methods are available. So now I will going to like I will explain boolean. So what is boolean here? So boolean is one kind of data type is available in our Java language. So what is going to do is going to provide by default true or false. Is going to provide by default true or so true or false. If same thing like so once we add an object, into the our collection, so what it's going to do is going to provide the true. At first time, if we are trying to add an object into the our collection, so is going to return true. And the same object again we are trying to add. So what's going to return is going to return false. So using the return type, so we can recognize the object is already added into our collection or not. So we can identify the same way. So how many methods are having the boolean type? So all the methods are is going to return true or false, right? So same like we can add all collection objects at a time, and we can clear all the methods, all the objects from the one collection objects. So we want to know so the particular object. So we are passing an object here. So this object is available in our particular collection. If it is available, is going to return true. If it is not available, is going to return false. So this is the purpose of the contains method is going to work. The same way we can use the equals method to identify the given objects available in our collection or not. So this is the way we can use. So it is an is empty or not. The collection is empty or not. So we can check using the is empty method. And so we have the remove and the remove all method. So if these two, if you want to remove the single object, so we can use the remove. And if you want to remove all object at a time, so we can use remove all method. And using the size, so we can get the how many objects are stored into the our collection. So and I'm going to write syntax about the collection interface. So like public interface collection, and is going to take e. So what is e? So e is in the sense it is an a so generic type. So it is in a generic type. So generic type in the sense so previous the generic so this is the generic type we are going to call. So this generic is available from Java 1.5 onwards. So before 1.5, so we don't have a generic option. So why the generic option is added into 1.5? So I will see the before drawbacks of the generic concept, and how the generic is came into the picture, and how the so what we can call drawbacks is going to eliminate in our Java 1.5 onwards. See, so as I said, using the collection, we can store multiple objects, right? Using the collection, we can store multiple objects. So for example, so just imagine, so in our example, we don't have a generic concept in the sense, so this picture is not available. So what's going to happen here? So simply we can store another object also. For example, it is a so test. So it is a new test. So just imagine the test class is already available. So we can store the different types of object. So here it is a student object, and again we are passing into the test object, because these two are the different types. So these two are the different types. So in some cases, so we are going to get some class cast exceptions. So we are going to get to some class cast exception. So for these elimination, so for these eliminations, they introduce generic concept. So if you are providing a generic concept, what's going to happen? So we are going to store only the particular related object. So particular object in the sense, so we specify the student. And if you're trying to add any other than student object, at compile time only, we are going to get an error. So this is the advantage we are going to get it using the generic concept. And so as I said, so these are the methods are available in our collection, right? So 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 what is going to happen here, it is going to throw some kind of exceptions. So because so some kind of exception in the sense, so we have what we can call it as, like, let me here. So while adding an object into the collection, so if we are adding the different types of object, if you are adding the different types of object, so what's going to happen? So the add method is going to throw some exception called unsupported format exception. So unsupported format exception is going to throw. And in collection, if you're trying to pass any null values, so null values in the sense, so null values in the sense, so what I'm doing here, so simply I'm passing null. So if you're trying to pass null, some collections objects are going to throw null pointer exception. And the same, like, if you are trying to get an object out of the memory, so for example we have four objects are stored, and we are trying to get a fifth object, so that is not available in our collection. So in this case also we are going to get an exception call. So what is the exception? So illegal state of exception we are going to get it. And the same way we are going to get an illegal argument exception also. So when we are passing the different types of object, so in this case we are going to get an illegal argument exception. So these are the default, by default exceptions we are going to get it. Because so if I'm going to open any collection object, so I'm going to open any collection object, we will see array list. Okay, let me go to here only. So this is our array list is an implementation class. So here, so we have add method, and if you see, so it's going to throw some exception called array index out of bound exception for add method. So same way, this add method also is going to throw some exception. So we will see what kind of exception is going to get it. So again, if you see, same array index out of bound exception is going to throw. If you are giving an out of index number, so same way, so these are the some default exceptions are implemented by so Java people. And see, null pointer exceptions. So null pointer exception, as I explained, null pointer exception. So one more exception called array store exception. So we have the different types of exceptions. So if we are going to give the different types of values, or if we are accessing out of like, so out of length of the particular object, some each case we are going to get an exception. So these are the main like most recent exceptions are is going to repeat it. So first is null pointer exception, and unsupported operation exception. Unsupported operated exception. So and illegal argument exception, and illegal state of illegal state exception, and we have class cast exception. So when we are going to see this class cast exception means, so for example, here we added student object, and so if you are trying to add another object into the collection frameworks, for example, as I said, it is in the different person object. So in this case, so we are going to get a class cast exception, because so what we defined here, so the array list, it's the collection framework is going to take as a student type objects only. And if you are trying to store the different types of objects, so in this case, we are going to get a class cast exception. And before moving into the other interfaces, so we will see the basic concept of how collections are introduced, like what are the interfaces are available earlier and how many interfaces are added as of now. So we will see, right? So the early days, so we have the interfaces called dictionary and vector, stock and properties. So these are the four classes are available at initial days. Initial days means, so when the Java is introduced, so we don't have the collection frameworks. At 1.2 version onwards, the collection frameworks was introduced. At the introduced in time, we have only four classes. So what are the four classes are available? Like, so here only I'm going to write. So the four classes names called dictionary, so dictionary and vector, stack and properties. So these are the four classes are available at initial version called Java 1.2, right? So after that, so they added based upon the like new version. So they added these collection and list set and queue interfaces. So and so these interfaces having, as of now, these are the implementation. Along with these implementation, we have some other implementation classes. So as I said, one is an array list, and we have the linked list, hash set. So linked hash set, tree set, and so we have the different implementation classes are available. So we will see and so the implementation class part we will see in the tomorrow's class. So today we will observe only the interface part. So how each interface is going to work, and what are the specific methods are available to the particular interface, right? So this is all about the collection interface. So now, so we will move to the list interface. So I'm going to open so another one. So here we can write list interface. So this is also same, is going to take a generic type call e. So is going to take the particular, if you define any generic type objects, we need to store the particular generic type objects only, right? So now, let me, so these list interface having some specific method. So what are the specific methods are having? So we will see. So here the methods name call void add int index and do e o object. And first I'm going to write the method, what are the methods that are available in the list interface. After that we can discuss each method, how the each method is going to work. Same like, so sorry, boolean add-on index collection obj. So collection obj in the sense it's going to take collection object as an a parameter, and do now get int index, right? Int index of into index of. So lost index. So remove int index. So and same like set, we have the set into index and do e obj. So these are the methods are available in our list interface. So list interface, see the magic here, what's happening. So if you observe any method, it's taking some index. So see index and do, so index and do index and do index. So what is mean by index? So because so the list interface is going to work based on the indexes. How the indexes are is going to work, show, I will show you. like, so we have an object called, so this is an implementation class I am taking. So this is the array list. So as we see in our so recent example, right? So here, so the student 1 and the student 2 and the student 3, so same like 4, 5, 6. So 0 and 1, 2, 3, 4 and 5. So so what's going to happen here? So void add method. So the add method, what's going to take here? Two parameters is going to take. So one is an index, one more is an object. Object. See, index in the sense. So if you are trying to provide index as an a one, and based on the index, this object is going to store. So here the obj is going to store. Here the obj is going to store, and I'm going to like provide the difference here, because we have in our collection interface also add method. We have the in collection interface also add method. So what is taking anything, simply is taking only object, but it's not taking any indexes, right? So here it's taking an indexes. So this is the difference between the two methods. So because here what's going to happen here, so if the one object is added, so it's trying to add, so the different indexes, because at first time the object is added here, and again second time using this add method, if you are trying to add an object into our collection, so this position number second, so position number third, so position number four, like the object is going to store, right? So whereas this add method, so how this add method is going to work, based on the index, because again if you are giving only second time also, if you are going to give the one, the old object is going to eliminate, and the new, sorry, deleted, the new object is going to inserted at the index 0, sorry, 1. So this is the way the list interface is going to work, and we have the some implementation classes, so we will see later. So what are the implementation classes and how it's going to work? So in the implementation classes, this is the one example. So same like add all, if you want to add all, so all the collection object into one particular indexes, we can specify an index, so we can add, and we can get the object based on our index number. So whereas in our previous, so we need to use get method one by one object or all objects are we are going to get it. But here based on the index numbers, so these are the index numbers, we can call it as, so 0 1 2 3 4 5, these are the indexes. If you give the index as an a 2, so what is inside the 2 object, what is an object is available, so this object is going to return, is in the sense the particular type of an object is going to return. Same thing, and we can know about the particular index of our object. If we specify an object, so we can get it in which index the object is stored. So this is the last indexes. So object is stored in last indexes is going to provide the number of the index number. So these are the int type. So int type in the sense is going to return the numeric values. So like 0, 1, 2, 3, 4, 5, some the numeric value is going to return. And we can remove an object using the indexes. And we can set an object using the indexes. So as I said, this list interface, most of the cases is going to work on the index basis. So these are the specific to the list interface. These are the specific to the list interface. And as I said, we have other one called set interface. So here the set interface does not contain any method. This interface does not contain any method. What are the methods are available in collection? So those methods are available logically, right? And we will see the queue interface. So in the queue interface also we have some specific methods are available. So we will see the queue specific methods, how the queue specific methods are available. So this is all about the syntax about the particular interface. So this is the generic type. This is also generic type because as I said, from Java 1.5 onwards, so whatever the collection framework, collection class or collection interface is implemented, so each collection is having the specific generic type. So now there is no the collection class or interface without generic type, right? So because we are going to store the particular object to eliminate some of the cast exception, so we are going to use the generic type and do queue interfaces. We will see. So in the queue we have some and okay. So so the purpose of queue interface, so what's going to do? So if we are adding an object into the our collection, so we want to get it first in, first out, right? So for this purpose, we can use this queue interface to get an object first in, first out. So what are the methods are available in queue interface? So we will see. So the methods called so the first method called element. So and the second one is offer, and the third one is pick, and so these are the methods are available in a queue interface. And these are the methods are available in queue interface. We will see the purpose of each method. The same thing as I explained earlier. So these methods are also is going to throw some exceptions like same exception, task exceptions. Okay. So class cast exceptions and null point exceptions or illegal argument exceptions or illegal state exceptions. So right, so no such element exception, no such element exception when we are going to get it, because so we are trying to give an object, those object is not available in our the particular collection. So in this case we are going to get an no such element exception. So 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 using the element method, so we can get in the what are the collections are available in our queue interface. So how the offer method is going to work. So offer in the sense is going to add an object into the queue, and so at first time is going to return true. The object is newly added, and if you are trying to add again and again, So without adding an object, just this simply is going to return false because the same object is already existed in our collection. So the peak element, what's going to do? So it's going to return the objects. What are the so peak objects are and pull object that's going to do same perform like it's going to get an object from the particular collection. But whereas in peak method, if the object is not available, so it simply returns null. But whereas in pull is going to throw, so no such method exception. So see the difference here. These two methods that is very much important. So peak method is returned simply null if the object is not available, and whereas the pull method is going to throw an exception if the object is not available. And we want to remove an object from the particular collection, so we can use the remove method. So these are the specific methods of the queue interface. And now we will see the relation about the collection and the list, set and queue. So how it's going to have, see here. So this is an top level interface, we can call it as. And this is the one more interface called list. So what is the relation here? The relation is called extends. So the relation is called extends. So if you know any some of the inherent concept, so it is easy to identify. Because so extends in the sense what's going to happen, so what are the methods and what are the properties are available in our collection, so those are logically available into the our list interface also. So this is the way the extend keyword is going to work. And now I will show you how the extends is really is working or not. And if you see array list class, if you see the array list class, so see it is an implementation of list interface. You are able to see, right? This is an implementation class implements. And so if you expand abstract list here, if you see the list interface, and if you expand the collection, so here the collection is available. So this is the way the relation is having. So from the collection, all the methods are available into the abstract collection. So from the abstract collection, all the methods are available into the abstract list. So from the abstract list, so all the methods are available into the array list. So this is the flow of execution or flow of execution in the sense we can call it as. So this is the way what are the methods are available in our collection. So those are available into the list interface. The same thing like we have set, we have set. So this is also same extents. And we have queue queue also extend, because these are the all interfaces only, because these three are the interfaces. So it's going to use extends keywords. So if we have any class, so we are going to use implements. And if we say implement list interface, and just ignore these methods, these interfaces as of now. So we'll see later each interfaces, but up to here using what keyword we are using here, implements. So if you know some of the inheritance concept, it is easy to identify how the implement keyword is going to work. And so this is the way all the methods are available into the set interface and queue interface also. And the set interface having some more interfaces called sorted set. So simply I'm writing ss, and from the sorted set we have the one more interface called navigable set. So these two are the more in, so sub interfaces of set interface. And see, so still here we are using extends keyword, and here also we are using extends keyword, right? So this is the flow of the part one collection. And so tomorrow we will see implementation of this part one, so how the each implementation class is available, and how the each implementation class is going to work tomorrow class. So we will see each of the implementation classes, and once the each implementation class is completed, so we can move to the part two called map. So the part two called map, we will see how the map is going to work. So we can see in tomorrow the same time. So I'm going to wrap up the today's class.